Hello everybody and welcome to another session of our December Daily Challenges. Today is day 3. I hope you've really enjoyed today's session. For those of you who are joining us first time, Edyst is running a December Daily Challenges. This is day 3. The theme for that is dynamic programming, and we've had some very interesting questions. For those of you who are interested in signing up, you can go to this link mentioned here. One second. Yeah, so you could all check out this link that's mentioned here. You can go ahead and sign up for that. You're still eligible for prizes and stuff. The person who's on top of the leaderboard at the end of day 5, which is on Friday, is the person who's going to win it all. So you can still sign up now, complete the previous questions, and be eligible. If you are the first one to complete all of the 5 challenges, then you will win everything. It started on 7th December 2020, and today we had the third challenge. Every day 6 p.m. this challenge opens up, and the solution is released at 9 p.m. every day, which is as we are doing today right now. First to crack the challenge is on top of the leaderboard, as I already mentioned. And the major thing about this is we are doing it on the theme of dynamic programming. Now I know a lot of you are skeptical about dynamic programming, don't really like dynamic programming, and I would like to tell you that I receive a lot of memes like these about dynamic programming as well, and I can tell you that the reason for that is you've probably not learned it in the right way. I'm here to try to teach you in a better way. So all of the questions we are doing on dynamic programming are all fairly standard approaches that you can see in DP, and we're going to do that for a more in-depth understanding of not only this but all advanced concepts. To join our advanced bootcamp, the link for that is in the description below. I'll just tell you a little bit about it. You can also go on this link, and it's in the description below as well. We have more than 300 questions, previously asked questions of all of the product companies, and we do weekly sessions on all of these topics. Monthly assessments happen. We have hackathons. If you do good, we also refer you to many of these product companies as well. So yeah, if you are someone who's really preparing for product companies, not sure on how to go about it, do join up, and we'd love to have you in this course. If not, just try out our December daily challenges. These are free. There is no cost to these December daily challenges. It's free. You can try out. You can see your level in dynamic programming itself. So today's question is called dirty cells. Let's open the questions and understand what exactly these dirty cells are, how we're supposed to solve that. This is you would have seen this kind of question occur earlier as well. It has something to do with 2D arrays. So let's go ahead and try to solve this question. So you have a grid with n rows and m columns. All of the cells in this grid are initially infected. You are given the time in which each of these cells is disinfected. Each cell is disinfected exactly once. So it's basically like a grid, like not a 2 cross 2, an n cross m grid, like a 2D array. Each grid has a particular time where it will be disinfected. Now the thing is, if you are given the time when it is disinfected, so 1 means it's disinfected the first time, then at the next second will disinfect somebody else, in the third second will disinfect somebody else, and so on, right? Now the thing is, whenever a particular cell is disinfected, its neighbors get the infection. This kind of problem you might have seen somewhere in the form of windows. So when you clean one window, the liquid from that window can go to the other windows as well, right? Like let's say all the windows are together. So this is how generally this problem is described in other places. In this places, it's like the infection, while you disinfect one cell, the infection goes away from that, but it enters into a few neighboring cells. Now, which neighboring cells? As you can see, it says the infection flows into the cells I plus 1 j minus 1, I plus 1 j, and I plus 1 j plus 1. That is, all of them are in the next row, but it's the next row previous column, j minus 1, next row current column, that's j, and next row next column, that's j plus 1, right? Now, even though they may have been disinfected earlier, right? We'll look at this flow diagram, but even though those neighbors may have been disinfected earlier, if they got a new infection, they got the new infection. Okay. All right. At the end of all of this process, some cells will still be infected. We have to find the number of infections. What does this mean? We'll actually just do a simulation of this, how this works out in real time, and see how this works out, right? So for example, let's say this is the cell this is the 2D grid that's given to us. What are all the numbers inside? The numbers inside tell us the exact time at which they will be disinfected. So I've just copied this one here, and what this orange here means basically is all of them are currently infected, right? So orange or red or whatever you want to keep, they are currently all infected, and we want to basically get them disinfected, and we want to get them to a normal state. And when are they going to get disinfected? They will get disinfected at this time. So the first one to be disinfected will be this cell, right? This particular cell will be disinfected first. So let's actually just, shade it something else. Let's probably a blue. So it got disinfected, but as we saw, if it gets disinfected, its neighbors get infected. So its neighbor gets infected, that is the same row, previous column, there is no previous column, same row, same column, and same row, next column. So these two are infected, which they're already infected right now. But once they get infected, then what happens is their neighbors also get infected. So then this row till here will get infected, because for 8, 9 and 5 will get infected. For 10, 9, 5 and 15 will get infected. So this continues. That's what the question says. This process continues until the infection flows out of the grid. So after 8, 10, 9, 5, 15 being infected, then it can't really go further than that. So it stops there. Okay. Let's look at 2 now. So 2 is disinfected now, right? And then these are infected, which they're already infected right now. So we don't, and at that point, this also get infected, but they're already infected. So we don't really say anything. Then 3 is disinfected. So 3 is disinfected, and then these 3 are infected, and then below that, so that remains as it is. Now the fun part comes. 4 is disinfected. When 4 is disinfected, what will happen? All of the infections below it, all of its neighbors are going to get infected, no matter if they got disinfected earlier. So now, because 4 is being infected later on, it got disinfected, but its neighbors got this got, basically 4 is clean now, but 1 to 12 become dirty. And if 1 to 12 are dirty, then each one of theirs will become dirty as well. So 8, 10 will become dirty, which they are already. For 2, 8, 10 and 3 becomes dirty, right? And for 12, 10, 13, 10, 3 and 14 becomes dirty. Then further, their own neighbors will also become dirty, which they're already dirty, so we don't have to worry about it. Next, we go to 5. In the case of 5, let's try and find the same color that we had earlier. Okay, yeah. So 5 is infected. I think this is, yeah. Anyway, so 5 is infected right now. 5 is clean right now. 5 will be cleaned right now, but once it's cleaned, its neighbors will be infected. So they were anyways infected, so we don't really, it doesn't change much. They were all anyways infected. Then comes 6. Where is 6? Did we okay, in this example somewhere 6 is not mentioned, so I guess it's not happening. But in the real example, you'll obviously get a 6. Let's take the 16 to be 6 itself, right? Because this entire thing should have 16. So why is 6 not there? 1, 2, 3, 4. 1, 2, 3, 4 is here, 5 is here, let's say 6 is here, 7, 8. Okay, we'll continue as is. I don't think we should have a problem. I think one of them, 5 is twice, right? Yeah, 5 is twice, so we'll make this one as 6 instead of making that one. Yeah, so you got this. Anyway, so 6 is there. So now this 6 will be cleaned up now. So once this 6 is cleaned, we just mark it as clean. Okay, and its neighbors, there's no neighbors as such to clean up, so it goes as it is. Next turn is 7. So this is cleaned, right? But now this becomes dirty, and since those are dirty, then it flows below and makes these all dirty, and these flow below and make these all dirty, right? So then this will again go back to being dirty. Okay, let's come to 8, cleaned. So this is cleaned, but then its neighbors get dirty, which they already are. 9, this is cleaned, and there's no neighbors as such, because the neighbors is in the next row, and we don't really have a next row at this point, right? So 9 is clean. But now when 10 comes in, so 10 gets cleaned. 1 second, yeah. So 10 will get cleaned, but then this neighbors get dirty. So we have this, they got dirty over here. Okay, now it comes 11. 11 is cleaned. So when you clean up 11, it'll look like this, but then its neighbors get dirty. So these are dirty, and since these are dirty, then they flow further below and make all of these dirty. So finally this entire thing will become dirty again, right? Then we come to 12. What happens with 12? 12 is cleaned up. So 12 is cleaned, right? Now that 12 is clean, it will overflow and make all of its neighbors dirty, which they are. 13 will also become clean now. And then it makes its neighbors dirty, which there already are. 14 becomes clean now, okay, and makes its neighbors dirty, which they already are. 15 becomes clean, and 16 becomes clean, right? Okay, so all of these finally are clean. When 15 becomes clean, its neighbors, there's no neighbors as such, that is the row below, there's no row below. Similarly with 16, there's no row below. So finally you have 4, 2, 1, 2. About 9 infections. Yeah, you have 9 infections completely. Of these 16, you have 9 infections, right? So we can start making a couple of observations here. Number one, we could repeat this process, right? But that won't really be an advanced question if we just repeat the process. That is, if you try to repeat this process in code. For example, you actually go to one, mark it as clean, and but mark all of them as dirty. The problem you will get with that is this n could be really big, and if n becomes really big, so in the question n cross m could go up until 10 raised to 6. And so if you keep, like, in the worst case scenario, you will let's say if your first row is there, when the first row, if you disinfect, when you come down, when you come all the way, like when you disinfect this, you have to update the values of this, because of which you have to update the values of this, because of which you have to update the value. So finally you're updating all the rows in each second. There could be up to 10 raised to 6 second, and you're uploading you're changing the values of 10 raised to 6 values in 10 raised to 6 seconds. So that goes to 10 raised to 12. That's way too much, right? It's given in the question, by the way, 10 raised to 6. So that's way too much. You can't really manipulate this. You can't really do this entire process for the entire array, though that is one way of doing it. What is the other thing? Well, the observation we can make is, see, even though this 1 and 2 were disinfected at one point, because their neighbors, their above neighbors, got infected at a later date, or either they were cleaned up at a later date, their infection came down to me. So even though I may be clean first, if my neighbors get cleaner later on, their infection will flow to me and I can't really do anything about it. So if I am connected above to certain dirty cells, they're all dirty initially, to certain cells who are going to be cleaned later than when I am going to be cleaned up, I will be infected for sure. The only way for me to be clean is if I am cleaned up after everything else is done. So that's why 15 and 16, they're clean. 16 will always be clean because 16 will be the last one to be infected. Similarly, the first row will always be clean because the moment they're cleaned, they cannot be infected again because they have no neighbor above them. So the first row will always be clean. The last cell will always be clean because it will be the last to be cleaned up. But for everything else, what you need to figure out is when was the greatest time at which they are going to be infected, right? So let's see how to find that out. So let's say I have something like this, right? This is the observation we make, by the way. I'll just write that observation here. Each cell remains safe as long as its disinfection date, as long as cleaning date is greater than any reinfection date. So it is, as long as I am cleaned up after all my neighbors are done, then I will always be safe, right? What does that mean? Let's look at this, right? So for example, when I'm here, I'm at 11, right? For the first row, we can just assume that this will anyways become clean eventually. So we don't need to worry about it as such, right? Okay. When we come here at this point, yeah, so these will not count towards the infection basically because they will be cleaned up. You're supposed to count the number of infections finally, right? So the answer actually is not, these were the clean ones. So I'll just go back and I'll say, in the clean ones, what happens is these are 9 clean ones. So we actually have 1, 2, 3, 4, 5, 6, 7 disinfection. Sorry, 7 dirty cells. So our answer is actually 7. That's what we're looking for. 7 dirty cells, 9 were the clean ones. And the answer in this particular case would have been 7. Anyways, coming back here, we want to find the clean, we want to find all of the infected cells. We know for sure this will be cleaned eventually. We don't have any problem for that. For 1, we already have 1, right? But so forget its own cleaning date. We'll refer to this one over here, the original array. Let's refer to this array. And what we'll do in this one is, let's store when we are going to be infected, right? So let's just quickly do that. Store infection date, not the cleaning date, because the cleaning date is already mentioned over here, right? So the cleaning date is mentioned on the left one, cleaning date is mentioned here. We'll store the infection date over here. In this case, there is no reinfection, so we just do it because they will be cleaned up. We don't have any issue. For 1, for this cell, what will be the maximum infection date we'll get, right? It could get infected from 11 or from 4. Right, because it always gets infected. Like for any given cell, for this cell, it could get this cell can infect this one, or this one, right? The next row, same column, next row, previous column, next row, next column. Similarly here for 1, it could have been infected from 11 or 4. 7 can't infect 1, so it could have been infected from 11 or 4. So the latest infection date we're going to get is 11 itself, right? Similarly for 2, the latest infection date we are going to get is 11. For 12, the latest infection date we are going to get is the maximum of 4 or 7 or 5, which is 7. For 13, the maximum infection date we're going to get is 7. Okay. For 8, the maximum infection date we're going to get is 2. For 10, the maximum infection date we're going to get is 12. For 3, the maximum infection date for 2, the maximum infection date is not 2, by the way. Okay, let's come back here. Let's look at this in a better way. For 8, the maximum infection date is not 12. It's not 12. Why is it not 12? Well, if you look at it this way, what's going to happen is the 11 flows down here, right? So the 11 is coming down over here at this point, right? So in that sense, this 7 is also okay, we'll keep these 7s here, but what I'm trying to say is 8, while 1 and 2 will get cleaned up right before, 11 will dirty them again. So for 8, what we should do is we should check between 1, 2 and 11, right? So for 8, the maximum infection date is 11, because when those 1 and 2 will get infected, they will also then further infect 8 and 10. Similarly with 10, the maximum infection date is 11. For 3, what is the maximum infection date? The maximum infection date is actually 13, right? So we have 13 over here. And for 14, the maximum infection date is also 13, right? Okay. All right. So when it comes to 9, the maximum infection date is again 11. For 6 over here, it's again 11. For this 15, the maximum infection date is 14. And for this 16 over here, the maximum infection date is again 14. Okay. So now this is the maximum infection date we'll get. And what does this tell us? This tells us the cleaning date. This initial one tells us the cleaning date. Now for whichever cell which has a cleaning date later than infection date, it is going to be cleaned up. But for whichever cell which has a infection date later than cleaning date, then it's going to be infected. It's as simple as that. So we know these are going to be clean. If you look at this 1 over here and this 11, obviously it will get infected later than it will get cleaned. So 1 is dirty. Similarly, 11 will get infected later than it will be cleaned. So 2 is also dirty, this one. When it comes to 12, it will be cleaned at 12, but the latest infection it's going to get is at 7. So for sure 12 will be clean. Similarly, 13 will be cleaned at 13, but it will be infected latest by 7. So it will be cleaned after it's infected. So it's 13. Let's come here. For 8, 8 will be cleaned at 8, but it's going to be infected at 11. So it's going to be dirty. Same with 10, going to be cleaned at 10, but infected at 11. So dirty. For 3, it's going to be cleaned at 3, but infected at 13 itself. So it's going to be dirty also. 14 is going to be infected at the latest by 13 over here, right? But it will be clean by 14. So it will be clean. For 9, we have again cleaned at 9, but infected at 11. So dirty. 6, cleaned at 6, but infected at 11. So dirty. 15, cleaned at 15, infected at 14. So it will be clean. And 16, cleaned at 16 but infected at 14, so it will be clean itself. So we are now able to get, if we are able to figure out this infection date, we are now able to get whether it is going to be clean or dirty. Simply put, once we calculate the infection date, check whether the infection date is greater than the cleaning date. If it is greater than cleaning date, then increase the infections. If it is lesser than cleaning date, then don't increase the infection. It's as simple as that, right? So our approach finally comes down to take input for sure. For each cell, calculate when it gets the latest infection. If the latest infection is greater than the disinfection or the cleaning up, increase the number of infections. That's all we are doing. So how did we figure this out? How does this relate to dynamic programming and all of that? See, we are always using the previous value to tell us when it's going to be infected. So in the case of 8, which is the most instructive thing here, we are not just taking 1 and 2, because actually for 1 and 2, the latest infection date is 11. So if we calculate the latest infection date for our immediate neighbors, for our parents, then we will know when we are going to get infected, right? That's how we'll actually end up doing this question. Okay. So let's write the pseudocode and put it into code as well. And I'll be coding in Python because most of you like it, and also because it's pretty simple to look and understand it. But if you require us to do it in any other language, let us know in the comments. Probably in the next set of challenges, we'll do it in another one, right? Okay. So I'm taking this here, and yeah, if you like our challenges, etc., please do subscribe to this channel, like this video if you're liking it. Yeah, so that more people can come to know about it. Anyway, so this is our approach. So we're going to first take input. In input, what all do we have in case of input? We have so we have for the input format is first T number of test cases, then m is the dimensions, followed by the n cross m grid itself, right? Okay, let's do that. So in different languages, taking 2D arrays input is different. I'll be doing it in Python. So very quickly, T is equal to int input. So this is the number of test cases. For case in range T, that is, we're going to do this, and in each test case, first we're going to get the n cross m is equal to list map int input dot split. So we got the list, we got n cross m. Yeah, sorry for the brackets. And yes, yeah, so we got n and m, and now that we got n and m, we want to get that many elements, right? So what we're going to do is we're going to create a grid, right? And we're going to say for row in n, right, in range n, these are the number of rows we'll get. In each row we'll be getting 1D array, right? So we'll say that current row is equal to list map int input dot split, right? So we got a particular row. Now once we've received this row, then what we want to do, we want to append it to our grid. So we say grid dot append. Right, so this is one way. You could do it in many other ways. I'm just doing it in this way. So we now have our grid, right? So now we have the entire grid. What we want to do right now is go through that entire grid and make sure that we get the maximum infection rate, right? So we want to do that. Now go through grid and get the maximum infection date for each cell. Right? This is what we want to do. So for row in, we'll actually do it I and j. That's better. For I in range length of grid, and for j in range, this is for columns, length of grid of I. Right? Okay, these are all the columns. Now we want to go through each row and each column, and what we saw was that the first row won't really help us out, so we skip the 0th row. We don't even look at it. We say initial infections is equal to 0. Okay, now first let's figure out when a particular thing is going to be infected, right? To find out when it's going to be infected, we have to look at its 3 neighbors that could infect it, right? So it's the 3 top neighbors that could infect it, right? Let's call those as candidate 1s, candidate 2 and candidate 3. These are the neighbors that could infect it, right? And we say that candidate 1 is the previous row. So candidate 1 will be previous row, previous column, right? Candidate 2 will be previous row, same column, and candidate 3 will be put the comment here. Yeah, so previous row, all of them are previous row, only previous row, next column, right? So let's update all of them. So if the previous column has to even exist, right? So if in the case if j is greater than 0, only then you say that candidate 1 is equal to candidate 1 is equal to grid of I minus 1 j minus 1, if a previous column exists, right? And that will exist only for columns that are greater than 0, right? So that's one thing you're going to get. What next? So let's go for the second one. Second one will always exist because you're always going to have this. So can2 is equal to grid I minus 1 j. You're always going to have this one because the column will you'll always have a pre column. The only one you'll not have is in the first row, and we are anyways neglecting the first row. If j now we want to go to the last row. So as long as if j is less than equal to length of grid minus 2, not just length of grid, by the way, length of this particular row. What's the length of the row? Grid of I minus 2, length of grid of I minus 2, right? So as long as j is less than this, then we can also check the next element, right? The next column. So cand 3 is equal to grid of I minus 1 j plus 1. Okay. Excuse me. All right, so we got this, we got the three candidates, and any of these three candidates could infect us later than when we are getting disinfected, right? So what we want to check is the latest infection is equal to maximum of candidate 1, candidate 2 and candidate 3. So any one of these three could infect us. Now it depends on our current infection date, right? So if our current infection date, which is in our current cleaning date, grade I, grade J, is greater than this particular latest infection, right? Then we don't have any problem, right? So we don't really increase the number of infections if this happens, right? But the thing is, if this cleaning is less than this latest infection, then we have a particular problem, right? In this case, we are going to say infections is equal to infections plus 1, because this one will definitely get infected, right? So infections is equal to 0 here, infections is equal to infections plus 1, right? Okay, and we will also have to update our current grid value. We'll have to update our current grid value. Grid ij is equal to maximum of either take the latest day in which I'm going to get cleaned, right? Either I'll have this or the latest infection, right? This is to take care of that 8 and 11 case. Basically, let's say if I'm getting infected later on, I don't want to even say that I'm going to be cleaned later on, because if I'm getting infected later, that is what should be stored here, because for the next neighbors, this infection is going to cause them trouble more than like for example, I got cleaned up at 2, but I'm going to get infected at 11. My neighbor don't care that I got cleaned up at 2, because my 11 is going to go and infect them further on anyways, right? So this grid ij is equal to maximum of grid ij comma latest infection. That's the update we need to do. Finally, we'll need to just print infections. That's what we need to do. We need to just print the infections part. Let's run and check any okay. Yeah, we have not append, we have put a lot of wrong spelling for that one. So grid dot append. All right, again we have an issue, length of grid of I, right? For j in range, length of grid of I, object of type int has no length. Okay, we made some mistake here. If length j in range, length of grid of I, that means grid itself is not coming up correctly. In range, length of grid of I, and it's saying we've done something wrong in the loop over here. Just give me a second. In range, length of grid of I, type int has no length. Okay, so it's considering this grid I to be length. Why would it consider it to be a length even though we are appending m columns? Okay, let's actually just print this grid to find out whether we are even printing it correctly, whether we're taking input correctly. This is something I do at the start, but I guess I missed on doing that right now. So yeah, the grid itself is not coming correctly, guys. It's coming 0 1 2. So we've made a mistake there in terms of getting the grid. So for row in range end, current row is equal to t is equal to input. Okay, what are all the inputs that are going to come our way? We're going to get n comma m, and then we're going to get 3 rows and 2 columns. Okay, so we're taking the input incorrectly. For case in range t, n comma m is equal to list map int input dot split, grid is equal to some empty range. Okay, let's print n comma m as well, so that print comma m. Yeah, okay, n comma n is 3 comma 2. That's fine, that is completely fine. Okay, I got the issue. We are not appending row. See everybody, when I make a silly mistake, we are supposed to indent current row, not row. Row is the variable, current row is the current row that we're supposed to append, right? So yeah, even I can fall under that mistake. So we're getting the correct answer, but we're printing unnecessarily something else as well. We're printing the grid, so we don't want to print the grid, right? we should just do without printing the grade. So yeah, now we're passing the test case. This is the one given to us. This will be infected first, but anyways, it is going to be so this will be cleaned first, but again it's going to be infected because of its neighbors. This will be cleaned next, and this 2 and 4 anyways will be cleaned. So it looks like we have only 2 elements clean, that is both 3, 5, 6 and 1 will be infected anyways, right? That's what's going to happen. And yeah, we submit, we pass all of the test cases as well, right? So yeah, I think that's mainly it. I think one thing is here is, yeah, makes sense, okay. So this works, and once we submit it, yeah. So guys, again, just a reminder, we are calculating the number of infected cells, not the number of clean cells. So if you look at it over here, you had like 1 got cleaned first, but it was anyways infected again, so this is dirty. 6 will be clean because it's the last one. 5 will be clean because it again is the second last one, and the last one is not above it, so 5 will be clean, 6 will be clean, 3 will not be clean because 4 will dirty it. So 1 and 3 will be the only dirty ones left, hence we have 2 infections over here, right? So yeah, I hope you understood this question. Not a super difficult question to understand, but yeah, knowing how to store your values in a 2D array, figuring out how to traverse it, and not taking up too much space, all of that is what's required. And yeah, you could have simulated the entire thing, but in the simulation what you're missing out on is that you already have some previous information on when the previous infection happened and the previous cleaning happened. So we followed this approach over here. Hope you got it. If you still have doubts or questions, leave them in the comments below. We'll help you out. And do check out the remaining daily challenges. If you like such videos, if you like such daily challenges, let us know in the comments below, and hit that like button and also the subscribe button. We'll see you all next time. This was day number 3, dirty cells, day number 4 and 5. Only 2 more days left, guys. Go ahead, start preparing a little bit for dynamic programming, and if you need any help, reach out to us. Hoping to see more of you practice on this as well as our algorithms and data structures bootcamp. I'll see you all next time. Thank you everybody for joining in today. Thank you.